there, and welcome back. What we're going to do is continue our exploration into Riemann sums with an example of a parabola, f of x equals x squared plus 2. And we're going to find the Riemann sum to estimate the area below that graph and above the x-axis on the interval 0 to 4 using 4 equally spaced rectangles along the x-axis. And we're going to use the left-hand endpoint of each subinterval to determine the height of each rectangle. So here we have a hand-drawn graph of y equals x squared plus 2, or f of x equals x squared plus 2. And each interval is going to have width 1 unit, or should I say each subinterval. So that means for the first subinterval, which is from 0 to 1, this point right here is going to represent the height of our rectangle. On the interval 1 to 2, we'll use x equals 1 for the height of the rectangle. On the interval 2 to 3, we'll use x equals 2 to determine the height. And on the interval 3 to 4, we'll use x equals 3. So there are our 4 rectangles. And even though it doesn't look like they have equal width, they are theoretically have equal width. So all we need to do is find the area of each rectangle. Now, the height of each rectangle is determined by the value of the function. At x equals 0, this is the point 0, 2. So I'm just going to write the y coordinate here. So that's 2. At x equals 1, if we plug in x equals 1 to the function, f of 1 is equal to 1 squared plus 2, which is 3. So the height of that rectangle is 3. I'm actually going to write the height right where the height actually is. Why not? So then when x equals 2, the height is 2 squared plus 2, which is 6. So this rectangle here is 6 units high. And the last one, which is determined by f of 3, 3 squared plus 2 is 11. So, and just to complete the picture here, f of 0 is 0 squared plus 2, which is 2. So there's the heights of my rectangles. Now the total area, which is the Riemann sum. So remember, the Riemann sum is the sum going from k going from 1 to 4 of f of c sub k times delta x sub k, where c sub k are the values that we're substituting, so that would be 0, 1, 2, and 3. And delta x sub k would be the width of each subinterval. In this case, they're all the same. They're all 1. So that means that this is going to be, so f of 0 is 2 times 1 plus 3 times 1 plus 6 times 1 plus 11 times 1, which is just the sum of 2, 3, 6, and 11, and that looks to be 22. And that is the estimate for the area between the x-axis and y equals x squared plus 2, between x equals 0 and x equals 4. Now, as we can see, that area is an underestimate for the actual area because all of the rectangles are what we call inscribed. They are all underneath the curve. There is space between the curve and the rectangles, which means that there's actually more area between the x-axis and the curve. And one way we could close in on that actual area is to use more rectangles. We could use 8, 10, 20, 100, 1,000 rectangles to try to get closer to the estimate for the actual area. So there's our Riemann sum for 4 rectangles.